everyone, we're going to identify and graph the polar equation r equals 2 plus sine of theta. It says identify. This is going to be a Limacon without an inner loop, and I will show you the form for that momentarily. Right now, let's test for symmetry because we're going to have to graph this. And so we're going to test conditions 1, conditions 2, and condition 3. So for condition 1, we're testing to see if there's symmetry with respect to the polar axis, i.e. the x-axis. So what they want you to do is substitute in your theta with negative theta. So let's do that. R equals 2 plus sine of negative theta. It's understood that sine is an odd function, so we're going to bring this negative out front. You get r equals 2 minus sine of theta. Since these two do not equal, it means the test fails, and our Limacon is not symmetric with respect to the polar axis. So let's see if it's symmetric with respect to the line theta equals pi divided by 2, i.e. the y-axis. All right, so what we're going to do is take our 2. Let's write r first. R equals 2 plus, and we're going to substitute in our theta with pi minus theta. So this is going to be sine of pi minus theta. Now, if we get back to the same equation, it's going to the test will be good. If not, the test will fail. This has our form right here for sum and difference formulas. So let's expand this as 2 plus sine of pi cosine of theta. I'm going to put a little bracket here. Minus cosine of pi sine of theta. All right. Sine of pi is 0, and cosine of pi is negative 1. Two negatives are going to make a positive, so you're going to get r equals 2 plus, this is negative 1, so it's going to be positive sine of theta. Since our equation is the same as the original, then that means yes, this equation is symmetric with the line theta equals pi divided by 2. Now the pole one is really easy. All you have to do is substitute your r with your negative r. So it's not the same, so the test fails. The only time this test works is when you have a r squared for this one here. So this is what I mean by this is a Limacon. Our A is 2 and our B is 1. Since our A is greater than our B, that means we're going to have a Limacon without an inner loop. It looks kind of like the cardioid, but it's more of an apple shape. The cardioid is more of a heart shape. So since we know the symmetry, that it's symmetric to the line theta equals pi divided by 2, we're going to assign values of theta from negative pi divided by 2 and pi divided by 2. So we set up a table. We have theta, and let's start with our values. You have negative pi divided by 2, and then we're swinging it back around counterclockwise. Negative pi divided by 3, negative pi divided by 6, 0, pi divided by 6, pi divided by 3, and pi divided by 2. And draw a line here, and we have 2 plus sine of theta. All right, so let's evaluate this. This is sine of negative pi over 2 is negative 1, so you're going to get 1 This one's going to give you 2 minus square root of 3 divided by 2. That's approximately 1.1. Here we're going to get 3 halves, 2, 5 halves, and this is 2.5. This is 1.5. This one's going to be 2 plus square root of 3 divided by 2, which is approximately 2.9, and this is 3. So let's start plotting our points. At negative pi divided by 2, that's this line here, we're at 1, so that's right here. At negative pi divided by 3, we're at 1.1, so a little bit out here. Just estimate. And at negative pi divided by 6, this is this line. This is at 1.5, which is about here. All right, at 0, we're at 2. All right, at pi divided by 6, we're at 2.5. So that's about right there. At pi divided by 3, we're at 2.9. That's close to 3. 1, 2, 3. All right. And at pi divided by 2, we're actually at 3. So basically, we're swinging around. We started at 1. We're coming back around up to here. Now that we know that we're symmetric to this line, theta equals pi divided by 2, I can adjust everything and just, instead of making another table, just kind of estimate my plots here. So this is going to come out a little bit. It keeps coming out at pi. This one was at what? 1.5. So here we'll be at 1.5. Then at 0, we're at 2. Then we're at 2.5. Then 2.9, which is very close to 3. So it comes back around. And there you go. Kind of looks like a apple-ish shape. And that's it. Thank you. Have a nice day. Bye-bye.